Hey folks, how's it going? We're moving on to 7.2. 7.2. So the basic idea of 7.1 to oversimplify things was we're just basically multiplying fractions. In multiplying fractions, you just say, okay, well, I can just multiply straight across. That's easy. Or I can reduce anything upstairs with anything downstairs. 7 and 14, that becomes a 1, that becomes a 2. The 6 and 20, they're both even, so take out a 2, that becomes a 3, that becomes a 10. Multiply across, 3 20ths. Okay, easy. Let's say we have 2/3 divided by 4/5. Okay, so multiplication's easy. Division is basically just one step away, so division is just multiplication by the reciprocal. Okay, you could multiply straight across, but try and reduce stuff. The 2 and the 4 reduce. That's about it. 5, 6. Okay, so that was basically 7.1, the concept, except we did it with, x's and stuff. So here's the concept of 7.2. 3/11 plus 5/11. Oh, the denominators are the same. Cool, so the denominator stays the same, and if the denominators are the same, then you can add the tops. 3 plus 5 is 8. Oh, easy peasy. Okay, so here's where it becomes a pain. 1/2 plus 1/3. Oh, in order to add or subtract fractions, the denominator's got to be the same. Okay, so it'll help if you can figure out the lowest common denominator, 2 and 3. Sometimes if you just give up, you just multiply them, or sometimes that is the lowest common denominator. They both go into 6. So the way I do it is I say, okay, I see a 2, I see a 3. What's the common denominator? What's the smallest thing they both go into? 6. Okay, this needs to be a 6. So I'd have to multiply by 3. So I multiply by 3 over 3. Okay, this needs to be a 6, so I need to multiply by 2. So I have to multiply by 2 over 2. And that'll give me 3 over 6 plus 2 over 6. Oh, the denominators are now the same, which means I can combine them. So the denominator stays the same, the common denominator, and 3 plus 2 is 5. Okay, easy peasy. So that's the underlying idea. So now we're just going to do it with x's and stuff and drive you crazy. Okay. So let's jump to problem 78. It says 7m over 2m plus n plus 4 over 2m plus n. Bottoms are the same. Cool. So that means I can just write the bottom, 2m plus n, and then 7m plus 4. 7m plus 4. Oh, well, that was easy. Yeah, they're going to get tough, don't worry. Let's try 80. I'm not sure if this one's going to get interesting, but it says 3. It has the letter s. I don't like s. I'm going to use x because s looks like 5. 3x squared over 3x minus 2 plus 13x minus 10 over 3x minus 2. Okay, the bottoms are the same, so this should be easy. 3x minus 2 on bottom. 3x squared plus 13x minus 10. Ooh, this trinomial looks like what I was doing in 7.1, so maybe it'll factor. Maybe off to the side you do the x method. I'm an expert, so I'm going to try and do the guess and check. 3x. I'm basically wondering if the 3x minus 2 is going to cancel. So if I put a minus 2 and a plus 5, 15 minus 2 is 13. Ooh, it factors. Basically, it's the psychology of the math book. There's a 3x minus 2 on bottom, so it'd be cool if there's a 3x minus 2 on top so that they canceled. Okay, so now, you see how I cleaned everything up, and then I go, oh, I need to factor that guy. So I factor it, and the 3x minus 2 and the 3x minus 2 cancel. What is left over? Just an x plus 5. So problem number 80 turned out to be a cool problem after all. Okay. Moving on. So adding, subtracting, same thing. Let's just try 86. 2n squared minus 18n minus 16 all over 4n minus 32. 4n minus 32. So rather than reducing and reducing right away. Since they're both 4n minus 32, I'm just going to go with it. So I like that they have a common denominator, and I don't want to mess things up. So up top is a 2n squared minus 18. Oh, God, careful. I messed up, maybe. Put that in parentheses. That'll make it look better. So it's minus sign. See how the minus sign is between the fraction bars on number 86? Minus sign, and then it's 18n minus 16. So if I put the parentheses, then it's going to be minus 18, careful, plus 16. Aha. Oh, this looks like what I was doing in 7.1. So notice what math is all about. We'd learn something new in order to bring it back to what we just learned. Okay, so we did one extra step, and now we're in 7.1. Cool, let's clean this up. Downstairs, I'll pull out a 4, n minus 8. And then, you see how there's an n minus 8? I'm going to suspect that's going to happen up top so that things cancel, so the problem's interesting. It's not definitely going to be there, but it might be. So right here, maybe you do the x method. I'm going to be lazy and do the guess and check method. So 2n times n would give me the 2n squared, and there's the n minus 8, and there's 16. So I'm just going to be hopeful and put n minus 8, and then see positive 16, so minus 2. Negative 16 minus 2 is a minus 18. Aha. Again, if you didn't like my fanciness, just do the x method. N minus 8s cancel. So what does that leave us with? It leaves us with a, put a little arrow there, we have upstairs a 2n minus 2, and downstairs just a 4. Ooh, 2n minus 2, can't I yank out a 2? Yes. Okay, so now the 2 and the 4, 1, 2, little arrow. What's left over? An n minus 1 sitting on top of 2. Ta-da! Okay. So that's about, okay. Let's do 92. 92. So we understand the basic game. 20w. 5w minus 2 plus 2 minus 5w. Ooh, remember it'd be a lot cooler if it was 5w minus 2. Can't I, if there's a minus sign, can't I just spin things and add an extra minus sign? Remember that trick I keep trying to explain poorly? Okay, so here's what I would do. 5w minus 2, cool. It'd be a lot better if this was 5w minus 2, so couldn't I just spin it? And if I spin it around the minus sign, I just need to pull out a minus sign. Okay, so now the bottoms sort of look alike. Let me write it a little bit prettier. So 20w, 5w minus 2. And what if this minus sign, what if I just kind of brought it there? I moved it out in front, so it's now minus 5w minus 2, 5w plus 6. Okay, make sure you're cool with this, what just happened. This is a common occurrence. 2 minus 5w, I wish it was 5w minus 2. So I spin it and change that sign. Spun, sign changed. Ah, so please pause, make sure you're cool with what just happened. That trick's going to keep happening a lot. Okay, so now that we've got the common denominator, should be easy. 5w minus 2 on bottom, up top, 20w. Be careful with this minus sign. It's minus 5w minus 6, minus 5w minus 6. It distributes to each of them. Okay, we're getting there. 20w minus 5w is 15w minus 6 over 5w minus 2. Are we done? I think I can factor something out from there. Looks like I can pull out a 3. So if I pull out a 3, that leaves me with a 5w minus 2. Aha! Bye-bye. So 3 over 1, which is just 3. Done! Circle it? Sure. Okay. So 99 through 105, they're just looking for the common denominator. Oh, God. I'll do 100. Number 100, that is. They're just preparing us for the next section, which will be more involved. So 100. They say, what if you have 8 over y squared plus 12y plus 35? And what if you have 3y over y squared plus y minus 42? Okay, in the following exercises, find the lowest common denominator, rewrite them as equivalent rational expressions with the lowest common denominator. Okay, we're trying to get the denominators the same. So again, it's going to help if you're getting good at factoring. So you do the x method, I'm going to do the guess and check. Y squared is y times y. What times what is 35 but adds to 12? Also, there's a little trick, right? The positive means the signs are the same and they're both that. So plus, plus. And hopefully you said 5 and 7. Okay. So y times y gives me y squared. And then what times what is 42? Oh, but there's a minus sign. But their difference is y. So basically, the minus sign means the signs are different. The signs are different, and the bigger guy gets that one. So the bigger guy gets the positive. So 7 times 6, so 7, 6. Signs are different because that thing on the right over here, signs are the same, and they're both that. Okay. Signs are different, and the bigger guy is positive. Oh, the bigger guy is 7. Positive, minus. Double check. Negative 6, positive 7 is 1. Ooh, multiply, negative 42. Aha. Okay. So far, everything's mellow. And now here's the weird part. Okay, let's see. So we're trying to get a common denominator. A y plus 7 here. So I see a y plus 5 and a y plus 7. A y plus 7 and a y minus 6. So if I need the bottoms to be completely the same, they both have a y plus 7, so that's good. This guy has a y plus 5. This guy doesn't. So this guy needs a y plus 5. That pen didn't work. This one needs a y plus 5, so let's put a y plus 5. I'll go over it in black ink. So this guy needs a y plus 5. Okay. And this guy, it's got a 5 and a 7. It needs a y minus 6. Oh, whoops. Go back over here. If I put a y plus 5 downstairs, don't I have to put it upstairs also? And over here, this guy needs a y minus 6. So if I put a y minus 6 downstairs, I need to put a y minus 6 upstairs. Aha! So now, you see, they have the denominators the same, and then that's how it affected the numerators. So yeah, so that's our answer. So it's just this over this, and this over this. Okay. Let's see. That was 100. Okay, 108. Let's save a tree. 108. 1 over 12a cubed b squared plus 5 over 9a squared b cubed. Okay. Let's see. A 9 and a 12. 9 and 12. What's the smallest number 9 and 12 both go into? Lowest common denominator. It happens to be 36. 9 goes into 36. 12 goes into 36. Okay. So 36. So this one needs to be multiplied by 3. So let me multiply by a 3 and multiply by a 3. If I multiply the bottom, I have to multiply the top. So this guy needed to be multiplied by a 4. And so multiply by a 4. Before, after, it doesn't matter which order it's in, right? It's just multiply, okay? So the number part matches up. There's a 36 on bottom. There's a 36 on bottom. A cubed, a squared. Okay, so this guy needs an extra a. So let me multiply by an a. Okay. So now there's a cubed on bottom, and now there's a cubed on bottom, or there was here. This one's a b squared. There's a b cubed. So this guy needs a b. So let's multiply this bottom by a b. If I multiply the bottom by a b, multiply the top by a b. Okay, so now if I rewrite things, what you'll see is I have 3b over 36 a cubed b cubed plus, up top, 20a over 36 a cubed b cubed. bottoms are the tops are, the bottoms are the same. So if the bottoms are the same, we just need to write it once. 36a cubed b cubed, and then the top is just this plus that. I'm going to put the a stuff first because it looks prettier. 20a plus 3b. Oh my, oh my, oh my. That was 108. Okay, on to 110. Let me double check that this is recording. Okay, 15 minutes in. Okay, 110. It uses s. I'm going to use x because it doesn't matter. 4 over x minus 7 plus 5 over x plus 3. Double check you wrote it down correctly. 4 over x minus 7. Okay, cool. I wish I would have wrote it a little bit bigger. So this one is actually pretty easy because the bottom, think of x minus 7 as being in parentheses and x plus 3 as being in parentheses. So what does this guy need? Oh, it needs an x plus 3. So multiply by x plus 3. So imagine if I put x plus 3. So multiply this by x plus 3. And then this guy needs an x minus 7. X minus 7. So multiply this by x minus 7. Okay. So now the top, I should have put this in the center of paper. So this is now 4x plus 12 plus sign plus 5x minus 35. So up top we have a 4x and a 5x is a 9x. 12 minus 35. Ugh, too tired. 12 minus 35. Enter. Minus 23. And on bottom is just that x minus 7 and that x plus 3. Ah, now it looks like 7.1. Can I factor anything out? No. Cool, so I guess I'm done. Okay. Let's try 112. I don't know if I explained that one very well. Or at all. Ha! Okay. 112. Let's see. 112. Put it right here. 4 over 2x plus 5 plus sign. I'm learning. 2 over x minus 1. 112. 4 over 2x plus 5. Okay, so I like to think of the bottom. It's a binomial, so put in parentheses. It's a binomial, put in parentheses. So the common denominator would be 2x plus 5 times x minus 1. So this guy needs an x minus 1, so put an x minus 1, top and bottom. This guy needs a 2x plus 5. 2x plus 5. Bottom's the same, bottom's the same. Cool, so that means we only need to write the bottom one time. This is a much better explanation. Okay, now let's clean up the top. That's going to be 4x minus 4, and then that's a plus 4x plus 10. 4x, 4x. 8x minus 4 plus 10 plus 6. Factor this out. I can pull out a 2, leaving me with a 4x plus 3. Does that cancel with anything? No. Sometimes they'll cancel. So it looks like we're done. So 2 over 4x plus 3. So we always leave our answer in factored form. That's prettiest. And that one wasn't so bad. Circle it. Sure. Okay. Easy, 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 easy. Okay, 118. 118. Eight over 4n plus 4. Plus sign 6 over n squared minus n minus 2. 118. 8 over 4 plus 4. Okay. Factor, that's a 4. N plus 1. Factor, that's an n minus 2. N plus 1. See, negative 2 times that gives us that. Negative 2 plus 1 gives us negative 1. Okay. So, ooh, this is what we're doing in like problems like 99 through 105. So, let's see. 4. Okay, so this guy needs a 4. So, I'm going to multiply by 4. So, multiply by 4. Okay, n plus 1, n plus 1. This guy needs an n minus 2, so I multiply by n minus 2. N minus 2. So 4, n plus 1 minus 2, 4, okay, so it matches up. The order doesn't matter on bottom. Okay, so everything's good to go. The bottom is 4, n plus 1, n minus 2, and on top, let me clean it up a little bit, 8n minus 16 plus 24. Minus 16 and then 24, what is that? 8. That's an 8n plus 8. 8n plus 8. Are we done? No. This 8n plus 8 can be factored, so pull out an 8, n plus 1. Oh, those n plus 1s will cancel. Boom, boom. Okay, dust settles. What are we left with? An 8 up top, and downstairs a 4, and an n minus 2. Are we done? No, the 8 and 4 cancel. 4 goes in twice, 4 goes in once. So, 2 over n minus 2. And now we're done. Ta-da! Okay. Okay. One more, and then I'll take a pause. Minus signs. We'll do 134. So it's the same game over and over again. 134, they put a minus sign. No big deal. 4 over, notice how I'm wasting a lot of paper. It's easier that way. X squared minus 6x plus 5 minus sign 3 over x squared minus 7x plus 10. Did you write it down right? Did I? 3. Okay. Factor x 5 and 1 minus 5. The signs are the same and they're both negative. Minus 5 minus 1. Signs are the same and they're both negative. Ooh, they both have minus 5s. Okay. So this guy here on the left needs an x minus 2. So let me multiply by x minus 2. If I multiply the bottom by x minus 2, multiply the top by x minus 2. This guy needs an x minus 1. Multiply the bottom by x minus 1, multiply the top by x minus 1. Okay, so the bottom's all taken care of. X minus 5, x minus 1, x minus 2. And up top, let's clean it up a little bit. 4x minus 8. Careful, think of it like a minus 3. So minus 3 times x, minus 3x. Minus 3 times minus 1 is a plus 3. Okay, let's combine like terms. 4x and a minus 3x is an x. Minus 8, positive 3. Minus 8, positive 3, minus 5. Are we done? Nope. See how the x minus 5 up top? Put it in parentheses, it looks prettier. Bye-bye. Okay, so are we done? Basically, 1 over, right? It's not just nothingness, there's technically a 1. X minus 1, x minus 2. Woohoo! And then we do it with 3 pieces. Okay, I'll do one more. Good gosh. So same thing over and over again. 142. 2q over q plus 5 plus 3 over q minus 3 minus sign 13q plus 15 over q squared plus 2q minus 15. I'm hoping this thing factors like that. If not, it's just a big mess, but let's hope. Let us hope. q plus 5 minus 3, 5, multiply that, add, yes. Woo! Okay. So now, the bottoms, let's see, there's a q plus 5. So the bottom here, this guy needs a q minus 3. So if I multiply by q minus 3, then I multiply by a q minus 3. This piece right here, it needs a q plus 5. So if I multiply by q plus 5, then multiply this by q plus 5. Q's looking ugly. Q plus 5. And this guy, he's good. Leave him alone. Okay, let's clean this up a little bit. That's a 2q squared minus 6q. Should I have been turning this light on the whole time? Is that better? Good gosh, my bad. Does it look better? Can't believe you didn't have the light on the whole time. Let's see. 2q squared minus 6q. 3q plus 15. Right, just distributing. Just distributing. And then that guy. So what do we have? The bottom is q plus 5 times q minus 3. And up top we have a 2 squared. Let's see. 2q squared. A minus 6q, a plus 3q, and a minus... let me deal with that minus. So minus, talking to each of them, is minus 13q minus 15. Okay, so I'm trying to keep track of all this stuff right now. So q squared, 2q squared. Okay, q stuff. Minus 6 of them, plus 3 of them, minus 13. Minus 3, so minus 16 of them. 16q. God, q's hard to draw. But number stuff. Plus 15, minus 15, so those guys cancel. Okay. So then, are we done? I don't know. The top, it looks like I can factor it more. So if I pull out a 2q, so let's put a little arrow. Pull out a 2q, that leaves us with a q minus 8. 2q squared minus 16q. 2q, q minus 8, q plus 5, q minus 3. Okay, so nothing really canceled. It's fine. And if nothing canceled, just double check. 2 squared minus 6q, 3q plus 15, minus 13. Yep, looks good. Ta-da! Okay, how long was that video? 27 minutes! Oh my gosh. Okay, and there's still more of 7.2. Yay!